Hello, I'm Flávio Marques. I'm a product line manager for data center and enterprise connectivity in Furukawa Electric Latin, a company of Furukawa Electric Japan. And I'm going to present you some research and some developments that we are working on in order to support the infrastructure for future technologies that are coming with COBOL. I'll start showing you that the first thing that we used to do is to evaluate and see how the topologies will make difference and how the impact of all the different form factors impact on the optical connections. We're talking about COBOL, but also we need, whenever you're using a pluggable or a co-package optics, you need to connect them using a cabling system. So here we in Furukawa Electric Latin, we develop all the connection and all the cabling system for the group. Furukawa is involved in a lot of optical technology, including lasers and special photonics and special fibers. But here what we do is to take a look at every application, take a look at every topology possible, and see if the cabling is flexible enough to support this application that there are available today, or the technology that are coming. So these are some examples of different form factors, different connectors, and different applications that can be used on a traditional or a future cabling system that is modular, that is flexible, and it's able to support changes in a very short time. What's the next challenge for us is the migration from a traditional pluggable optics to a co-package optics, or something that will be represented not only by a cage to introduce a pluggable optics or transceiver, but only a connection that will be able to perform the connection straight to the board, optical straight to the board, or even straight to the processor or to the board. What we are looking for is that what is the future of this connections? It will be MPO16, will be the next generation of very small form factor connections. What we are developing in our laboratories is different topologies, different connectors, and see how it goes in terms of performance, in terms of attenuation, in terms of flexibility. In the other hand, we in our laboratory, we are working on real tests for real applications. This is an example of our 400G test in a real environment. And when I say real environment, it means that it's not a desk test, but it's a real data center environment, including temperature, including raceway, including racks, everything that you have in your data center, and the test of bit error rate. So it's the limit for the physical level or the physical layer. The real test for 400G was the last one. It's the top of the technology on the Ethernet, and we now in IEEE are working on 800G and 1.6 terabits per second. So we have access to the very first alpha products from vendors, and as soon as we have some alpha, we use to make this test on Furukawa and our labs down here in Curitiba, where we develop all the cabling systems. So we believe that the optical in the data center will have a very good way ahead. So we are working on 1.6 terabits. That's unbelievable speeds from years ago. And now we are very excited to support this effort on have all the fiber to the processor, close to the processor, close to the board, helping COBOL to develop these technologies. If you want more information, please visit furukawalatin.com and see the latest development on optical technologies that we offer to our customers. Thank you for your time, and see you soon.